In this video, we're going to talk about the abstract keyword, abstract classes, and abstract methods. So basically, an abstract class is a class that can A, not be instantiated, and B, contain abstract methods. An abstract method is a method that has no implementation on the class it's declared in, but can have an implementation on its children. So I'm going to go ahead and demonstrate this real fast.
It can or is required?
It's required. Well, maybe not required.
Okay.
It's required to ultimately have a implementation on a non-abstract child, but you could theoretically have an abstract child. And I'll go ahead and demonstrate that, what I mean by that.
Okay.
So I'm going to go ahead and create a class called base1. And just to prove a point, I can go ahead and say object1 equals new base1. And obviously this is perfectly valid C# code. But if I were to add the abstract modifier to this class, we now have an error on the new keyword.
That is because this abstract class cannot be instantiated.
Exactly. Also, and if you remember, that's the first thing about an abstract class. Second thing about an abstract class is it can contain abstract methods. So I'm going to go ahead and remove the abstract modifier for a sec here, because I'm going to create a public abstract void my abstract method. And you'll see here that we cannot have an abstract method on a non-abstract class. So I'm going to go ahead and add the abstract modifier back into here, and you'll notice something's different about this method. This method has no implementation. In fact, the only way to not have a method that has no implementation is through abstract, extern, or a partial. Those are the only three cases where this syntax is allowed. But basically what we're doing here is we're defining a method and not giving it any code associated with the method. But the cool thing about this defining this method is we can use this method in any way we want inside of this base class without any fear of adverse repercussions. We can have output parameters, we can include it in expressions, we can attach delegates to it and all that stuff.
Well, you could just do a quick example, couldn't you?
Yeah, I could just go ahead and say public void my concrete method.
And the nice thing to point out to everyone is that within the abstract class, not every method is required to be an abstract method.
I was going to ask, actually, if all of the methods within an abstract class are required to be abstract themselves.
Meaning that by putting some implementation into methods that are indeed concrete methods within the abstract class itself, then by extending this abstract class into a derived class, it's going to inherit that implementation, that functionality from those concrete methods.
Exactly. So if I were to go ahead and create a concrete, and concrete is the antonym to abstract in the programming sense and the English sense. So now we have a concrete class, and you'll notice we have an error. We have abstract inherited member. My abstract method is not implemented. And that is because, well, obviously, there's no way for this code to work properly without an implementation to this method. We provide an implementation to the method by using the override keyword. So now we can say public override my abstract method, and we can go ahead and provide an implementation.
And you'll notice also that the error has gone away.
Exactly. So now instead of instantiating base1, we can now instantiate concrete class.
You misspelled implementation.
Okay, so now we have a concrete class that inherits from a abstract class.
So in a way, you can kind of look at this. Now don't freak out when I say this, but this is kind of like a more powerful type of interface in its own way, because we can actually carry implementation in here, but we can still force classes that are going to inherit this to implement very specific functionality.
Kind of like their own version of it.
Well, exactly. Abstract classes are commonly used with what's called the template method pattern. Mm-hmm. Template method pattern meaning this class may have a bunch of implementation code, concrete code, but one or two parts of it you might want to swap out depending on what situation you're in. So what you would do is you would factor that out into an abstract method, and then in your concrete classes you would provide your own implementations of that. Mm-hmm. There are another few important things about abstract methods. For example, I can have another abstract class. Let's go ahead and create a base2. that implements base 1, and remember base 2 is abstract, this does not error out. The abstractness of this method carries over through this class into whoever it implements. So I can change this implementation from base 1 to base 2, and it's the same thing.
But at the end of the day, when we get all the way down to a point where we have a derived class that can indeed be instantiated, we must provide an implementation for all abstract methods.
Yes.
Thank you.
Well, I mean, yeah.
Well, I said that a minute ago, but you said, well, yes and no.
Well, the no part was, I mean, we can do this.
Yeah,
but at the end of the day, if you want your code to be useful,
but well, at that point, Nelson, it's still an abstract class. It's not a class that's useful.
Exactly.
It does nothing.
Ultimately, if you need a class that's useful, you will have a concrete class which will override all the methods. And this override keyword, it's very important. It brings up a very common mistake that people say. A lot of people call overriding overloading and overloading overriding. Those are two different concepts. Overriding is what we're doing here. Overloading we will be doing elsewhere. So I just want to point that out, that this is overriding.
Okay. Correct.
In addition, another interesting thing we can do is we can have an interface called iInterface. That's a good name. And we can give them a method, like void method. And we can have our base implement this interface. And what's cool is we can actually implement this member as an abstract member. So I can say public abstract void method. And so what I've essentially done is I've passed on the burden of implementing this interface down the chain. And you see now right here we have another error saying that method is not implemented.
Right.
So yeah, as far as design and where you would use abstract classes, the main reason you'd use an abstract class would be, like I said before, for template methods. Another good use for abstract classes is if you have, like, let's say we have an iController interface. And then we have like one or two methods, like let's say invoke action or something silly like that. Now, let's say that this is, as far as the rest of the program is concerned, we just need to implement this interface. But let's say we have an abstract class that implements this interface in a way that makes reusing that implementation easier. So I usually will consider abstract classes to be an implementation detail, because what it allows you to do is it allows you to pass down some helper methods to ultimately fulfill an interface, but will help you down the road with code that you can use and reuse.
Okay.
So for example, I could say I have this, I'm going to delete this code now, and then this code real fast. Let's say this invoke action method, let's pretend that it takes in a string action name. And let's say that, I'm just going to write this in comments, that invokes a method on the current object of name action name. So what I've essentially done is I've written this cool little API that we can now inherit from base 1 and implement this interface in a much cleaner way than if we were implementing the interface directly. So that's pretty much all of the considerations as far as abstract. Except for you cannot have abstract and sealed on the same class. So if I were to say abstract sealed, I would get an error at the class level, because that doesn't make any sense. If it's an abstract class, that means it should be inherited from.
That means it must be derived from or extended if you're going to put any sort of concrete functionality to it at all.
But sealed means that you can't inherit it.
Exactly.
Right.
So the C# team could have theoretically allowed this to happen, but they were like, wait a sec, that's stupid.
Yeah.
So, yeah.
All right, fantastic. Well, with that, that's going to conclude this video with working with abstract classes and abstract methods. Thanks a lot.